Welcome to the Tomorrow's World Today podcast. We sit down with experts, world-changing innovators, creators, and makers to explore how they're taking action to make tomorrow's world a better place for technology, science, innovation, sustainability, the arts, and more.
In this episode, George Davison, host of Tomorrow's World Today on Science, interviews Dr. Kathryn McCarthy, director of the US ITER Project at Oak Ridge National Laboratory. They talk about Oak Ridge's contributions to scientific advancements, how Dr. McCarthy's background influenced her career, and the importance of innovation and diverse viewpoints in addressing global challenges. Now here's George Davison.
Well, welcome, Kathy.
Thank you. Happy to be here.
Well, thank you for making that trip out here. You know, we have so many people in this audience that are going to be curious about how you've achieved what you've done in your life, and I'm hoping you'll share what you can with us today.
I'd be happy to do that.
Okay. Well, then how about we start with some of the basics? A lot of the people out here probably won't know what Oak Ridge National Lab is and what you do out there. So could you share that with us?
Yeah, Oak Ridge National Laboratory is one of the Department of Energy national labs. And the role of the national labs is to do science and technology that eventually is applied in industry, that ultimately helps industry, solves big problems, big challenges.
Mm-hmm. So how could I engage a lab like that? Am I a business? Am I an individual? How do I bring problems to you?
So typically the way that works is connection with one of our scientists and engineers, or potentially connections with one of our managers. And we go out and we'll talk at conferences and things like that. Mm-hmm. So it's that initial discussion, working through, well, how could the lab help, put a plan together, go through the appropriate approvals, and move forward from there. And from our perspective, working with industry is key. Now, that hasn't necessarily been historically what the national labs have done. But for us to be able to take this science that we do and see it actually applied in industry, that's a really important part of what we're doing now.
Very, very good. Yeah, because you do want it to convert into something, right?
Yes.
So can we frame how important innovation would be at your organization? Like, how does that work?
Innovation is key because the problems that we have to solve, they're challenging problems. The reason a national lab would take something on is because you need a combination of unique facilities, unique capabilities, people looking at a problem from all different backgrounds to figure out how to solve it. And like I said, these are very challenging. This isn't your cookie cutter sort of thing. That's why you come to a national laboratory. So innovation is key.
I see. So people who think innovatively would be your most precious natural resource. Is that fair to say?
I would agree with that. And it's sometimes the innovation happens only because you've got this set of people with different backgrounds. Maybe one individually isn't the most innovative person, but they'll ask a question that makes you think about things in a different way.
Yes.
That's why that whole concept of diversity is important. Diversity from how you grew up, where you're from, your technical background, not technical background, because sometimes the hardest questions come from the non-technical people.
You know, that is so true, because that happens in our world over here too. And then the technical people have to say, what? You don't understand how that... And then they have to say it out loud. And then all of a sudden, the whistles and bells start to go off. We've seen that as well.
Yeah, it's true.
Good stuff. So for our audience, can you walk us through, what does a day in the life look like?
My job is really exciting. I really do have the greatest job. What we look at, if you look at the fission industry, the fission energy industry, we have operating reactors, but we're looking at how do we make them operate more efficiently, right? Economics is key. What are the next things we need to do so that carbon-free nuclear power can penetrate markets that it couldn't necessarily with the conventional big reactors that exist now? They're important, but we need to do more. And then you bring fusion into that. And this is a group of people, and my graduate work was in fusion. So that's that I've kind of done, not kind of, I've done about half my career in fusion and half in fission. The fusion side is the very creative side, right? Fusion reactors exist in the laboratory. They don't produce economical energy. And if you think about, you've got the temperature of 10 times the temperature of the sun, 150 million degrees centigrade here, And right here, I have 500 or 600 degrees centigrade. How do you do that? And so we look at ways to do that, and that combination of fission energy grounded in, well, ultimately, here's what you need to do, and fusion energy, let's think out of the box on how to solve these hard problems. You put those together, and it benefits both. So I've got the most exciting job in the world because I get to bring all those people together.
That's pretty interesting. I don't know how you figured that out, like how to navigate your fission and fusion world to create this interesting space. But I imagine you're going to need more people in that space in the future, right?
Oh, we are always looking for more people. Absolutely.
Could you tell me what in your background is what you drew upon that led you to your current position?
It's an interesting question. One of the things, as we're looking at how do we attract people into STEM, and the way specifically that we sell engineering doesn't typically appeal to, and I'll talk about women because I've looked at this quite a bit because it's one of the things I've tried to help with, and engineering tends to lag in STEM in terms of women and underrepresented minorities, more so than other fields. So we tend to sell engineering as hands-on sort of things, fixing things, building bridges, building buildings, and that kind of thing. And that works for a lot of people. And actually, that kind of works for me because one of the things I liked early on was putting things together. My parents there was a local theater company, and my parents would be in the shows over there, and us kids would be kind of waiting while they did their rehearsals, and we weren't interested in watching. But there were boards and hammers and nails and things like that, and I liked putting those things together. I just liked doing that. My parents got me one year a Lego set, which then they built on. I have this amazing Lego set, and I used to make these cars. It had a little engine. I could do all the, not an engine, a battery and cogs. So for me, it was playing with that sort of thing. And I really liked that hands-on thing. On the other hand, if we're really looking at appealing to a broad audience, the other way that we need to sell engineering is, in general, women tend to like to go into fields where they can help people. Engineering helps people every day, and we don't talk about that enough.
Sure does.
So it was really, a combination of those sorts of things. I have this great erector set, all these things that I actually saved and brought out when I had kids, and I'll bring them out for my grandchildren. And it was nurturing that kind of thing, and it graduated into, my parents were very clever, right? It wasn't we really think you should do this, but rather let's put these things in front of you that pique your interest. So I remember one year I got a Heath kit, and I got to put together a radio. So this is when I'd graduated to soldering and things like that. So all of those sorts of things helped me. It's not necessarily something that would help everyone, but that's part of the reason I think why I am where I am.
So exposure to STEM type activities, and then letting you have the freedom to choose and play and create what you wanted to create, right?
Well, and you talked about innovation. So here's another thing. I like to fish. I've always liked to fish. My parents would take us fishing. I've got 2 sisters, no brothers, so us 3 girls, and 2 of us really like fishing. My older sister doesn't like it at all. But we would catch grasshoppers. Okay. And grasshoppers are good bait for fishing, right? Worms are too, but they're pretty easy to catch. So Dad said, why don't you invent a container for grasshoppers so that it could help you to get it out and be able to put it on a hook. I worked on that. It was actually really never very good and never really got built. But my parents encouraged that kind of thing.
Right, that kind of thinking of, well, there's a challenge. Can you figure it out? Right? Yeah, that kind of there was a lot of that in my brothers and my upbringing as well, and a lot of science, a lot of go explore, go figure it out. Around here, we refer to it as go fail your way forward, Learn how to pick yourself back up off the floor. But, going back, you've mentioned some of the background of your parents. In general, did you have any other mentors that are, sticking out in your mind that helped to shape you?
Yeah, and really, as I look through my career, so I got to University of Arizona, and one of the professors there, I think he was actually emeritus even at the time that I went there, was Norman Hilberry. Dr. Hilberry was part of the Chicago Pile experiment, one of the very early demonstrations that led to practical applied fission energy. Dr. Hilberry took me under his wing. And he would talk with me, and he would encourage me you should think about graduate school, you should do this, you should do that. So that was absolutely true from a school, education perspective. And my parents always continued to encourage me, and my uncle as well. My uncle at one point was Deputy Undersecretary for Caspar Weinberger. So we got to tour, we got to go through Caspar Weinberger's office. He wasn't there, of course, and see those sorts of things. But Uncle Larry, I still call him Uncle Larry, even though he's 80 something now. But Uncle Larry was also somebody I talked to quite a bit about, what I should do and what are the opportunities. So I've been really lucky because I haven't really had to. I've had a lot of role models, a lot of people who really helped me.
That's a blessing. Let's imagine for a moment that you didn't have those mentors. What do you think you would have done?
That is a really good question. I don't know. I might have come this direction anyway. I have to tell you, I have not ever been one of those super organized planner people. Here's my 1 year, 5 year, 10 year. I've kind of been a little bit of not a pinball necessarily, but certain directions that I've gone, they've kind of fallen into my lap. I'll give you an example. Graduate school. I was looking at, should I go into nuclear engineering or should I go into nuclear medicine? And I looked into both and decided, I got to go to school too long for nuclear medicine. I'll do a PhD in nuclear engineering. By the way, that's probably not a good judgment on my. I think they're about the same amount of time, but that's okay. But I think all of us look for, one of the things I try and do now, because I recognize I was lucky. I had all that. I had that support system. I do try and go out and talk at the schools and trying to explain to elementary school children how nuclear fission works. That's like one of the hardest things I've ever done.
Oh, I can't imagine.
And I go and I'll talk at universities. I'll talk at different conferences focused on different groups of people. I think we all really need to do that. And it's interesting because I have had a lot of women, for example, come to me and say, I really appreciate you did this. You came and talked with us because I do look at you as a role model, which honestly I never really thought of myself like that. Well,
but look at it from where they're coming from. If they don't have mentors, they don't have, let's say, two parents at home, some of them don't have a caring hand to help guide them, right?
Well, and one of the things that several national laboratories do, and by the way, the first 25 years of my career were at Idaho National Laboratory. I know it very, very well. One of the things they did was the high school teachers workshop. They would bring in high school teachers from all over the United States. I can't remember how many states they ended up covering. They also had some foreign teachers, and they basically would teach them about nuclear science and engineering, nuclear science and technology, and give them the tools to be able to teach it when they went back home. Things like, here's a Geiger counter. Here's how it works. You can put it up against FiestaWare, and FiestaWare, you'll actually get a reading, right? Right. But the teachers, they need the tools to be able to teach. And I think that was a great thing that Idaho National Laboratory did, and that other national laboratories have as well, this sort of outreach, and Oak Ridge National Laboratory does outreach as well. I think it's part of our job to help with that.
I'm glad to hear you say that. So how important are STEM-based classes for someone interested in pursuing a career in your field?
They're very important. Now, one of the things I really liked about nuclear engineering is it absolutely is you need to have a good math basis, but you also have to have a good physics basis. It's very, very heavy in physics. So, well, I'll tell you something maybe I should have done back when I was younger. There were times when I crammed for a test, right? When you cram for a test, I'll admit it, you actually don't learn things as well as when you actually kind of learn it all along. Don't cram for tests. Actually pay attention to it. But that foundation is really key. And I did find myself in times in college, I'm in a class thinking, yep, probably should have known this, and had to kind of go back and learn it. So I would say do pay attention to those things. Do learn things, don't cram things.
Well said. Okay, so knowing what you know now, what advice would you give a person interested in entering into your industry today?
Ask questions. My industry is so broad. What is it that you like to do? Are you interested in the current fleet of fission reactors, keeping them going? And that's not as easy as it sounds. Think about having to survive very, very cold weather, things like that. There's all different aspects of the current fleet. Are you interested in the next generation? Do you like to look at ways to do things better? If that's the case, maybe you want to kind of go the direction more of research. And I think this is true for any field. There's so many different options, so many different paths you can pursue. So you're kind of interested in something, well, check into it, ask questions, but also don't ignore the other side of things, because engaging your creative mind. So I think for me, music helped me with my engineering.
Yes.
Because there's a lot of similarities. So try to do both.
There's a lot of engineering in music.
Yes, there is.
So, but probably the creatives in the music side don't want to think of it that way.
No, and actually to take the engineering piece of it, read the music, I can play the music and turn it into music, that takes the creative side, right? Your other brain, your other side. I always forget which is left, right. But yeah.
Can you talk a little bit about what you think the next big innovation in the nuclear industry is going to be and beyond?
I'm going to talk about fusion as the next big innovation in nuclear, right? Okay. Both nuclear processes, both fission and fusion. And there are absolutely challenges in fission too. But I think probably a lot of the other people that you're talking with will talk about that. So I'm going to talk about fusion. What we're doing in fusion is bringing a star to Earth. We talk about it like that, and you think about what does that mean and what does that take, and specifics. One of the things I would say, understanding materials. And actually this is true not just for fusion, but for almost any industry. When you get a failure, you can almost always, or quite often, tie it to some failure in materials, and so developing materials is important. So I think that the next big innovation that is truly needed, and we're working on this, is materials that can withstand extreme environments. And it's not limited to fusion, right? We talk about this when we put spaceships into, to go wherever they're going to go. They have to withstand heat, things like that. So I think that that's a really, really important area. And of course, tied into all of this is computers. And that's another area that is so much, when we talk about quantum computing, and don't ask me to explain it, but those sorts of innovations are key. Yes.
So I think when you say material science, maybe the idea behind that would be how to have things held together, even though you have extreme temperatures on both sides of the material in the middle. Right, so we're trying to control this temperature chasm, so to speak, right?
Yeah, and keep that really, really hot away from something that can't withstand the really, really hot.
Yes. How could I start to think that maybe I could get in there and help solve that problem, and that material science problem?
So it's looking at. I would first of all, you can do a lot of looking on the internet. Be careful what you read. Not everything is right. Go to the national lab websites, because they'll talk about the sorts of things the sorts of challenges that exist. When you've got a fusion reactor and it sees neutrons, energetic neutrons, more than from a fission reactor, the surface gets bombarded by lots and lots of neutrons, so much so that it changes the structure of the material. And we have to understand how that what is the behavior once it's changed, because you still need to have it maintain its integrity.
Right. I think we need to go back for just a moment, though. What does material science mean?
So think about the surface of this table, and this is what we see. If we actually enlarge it so that we're looking at the part of it on the order of think about the width of your hair, the average hair, like they're different. You go down and look at things at that level, they look totally different. So I see this flat surface, and I see that it's white. Well, if you look at it with powerful, powerful microscopes, that's not what you see. You'll actually see imperfections. You'll see little holes. You'll see, this is a composite, so it's got different materials. So I'll see the different elements. And understanding how those move, that's what makes this a table that works, or a table that, if I set something down on it, creates a stress that causes a problem.
Understood. So what we're talking about then is, when you, let's say, look at something through a microscope and you can see it down at the very, very, very small level, what are these particles? How do they all come together? How do they create some kind of a surface, right? And then there are thousands and thousands of different types of materials. And how can you bring them together? How can you combine them? How can you integrate one material that doesn't belong with another? Can that be figured out?
Yep.
So let's say that the material science area, knowing that it's an emerging area, are there particular places that I can learn about that?
Absolutely. You will find various websites and again, I would start at the National Laboratory websites, and the links are perhaps a bit more, you can count on them a bit more,
more
to be accurate. Thank you, reliable was the word I was looking at. You can certainly start there. The other thing, too, is kind of depending on what level you are, you can find some really interesting podcasts out there. For example, MIT has a series. They do a lot of their classes as podcasts. You can just go and you can access them for free.
That's right.
And I think doing things like that can help quite a bit. So it sort of depends on the level that you're at.
Well, Kathy, I can't thank you enough for coming in here today and sharing your wisdom with us.
Well, thank you. I really appreciate it. I enjoyed the conversation.
All right. Well, thank you. Have a great day, everybody.
Thanks for listening to this episode of the Tomorrow's World Today podcast. Join us next time as we continue to explore the worlds of inspiration, creation, innovation, and production. Discover more at tomorrowsworldtoday.com and connect with us on social media at TWT Explore. And find us wherever podcasts are available.